Okay, so hello everyone. This is lecture number 5 of motion in a straight line. This may be the last lecture regarding this topic. So, in this, we will start with the discussion about relative velocity. Then we will move on to the summary, and that will be the end of your motion in a straight line. Okay, so lecture number 5. So, I'm Samir Lawankar. Let's begin our discussion. Okay, so first of all, a course outline for you. We started with the introduction regarding this topic, in which we understood basically, as in why was there a what is basically motion, what are different sorts of motion happening around us. Then why okay, so the basic easiest way of motion is basically rectilinear motion. So rectilinear motion is basically what we'll just keep on revising also everything, because this is the end of everything. Let us remember everything for our greater clarity. So what is rectilinear motion? Rectilinear motion is basically motion in a straight line. Okay, so motion in a straight line has been explained, which is also what a rectilinear motion. Okay, so that is the basis. Okay, then also in this after this introduction part, we also understood one concept which is called as the frame of reference. So basically, what was frame of reference? The coordinate axis you take plus the clock. Plus the clock is nothing but your frame of reference, right? So that is basically your frame of reference. Okay, so if the frame of reference is changed, then the what we can say, the coordinate axis is also changed. Okay, so if the frame of reference is changed, then the answer related to, let's say, position, path, length, displacement will also change. If those are changing, the average velocity, average speed is changing, instantaneous velocity will also change. It depends upon the frame of reference. The frame of reference plays a very crucial role for our analysis. Okay. So that being said, what was doing more? Okay, so if the motion is apart from this, if it is in 2D plane, so we say that to be motion in a plane. Okay, so that motion in a plane is the next chapter after this, in which we will understand several different topics. Let's say projectile motion, then uniform circular motion, etc. Okay, so let's not go into that. Let's first complete this and then we can move forward. Okay. Fine. So in the second subtopic, we also understood about position, path length, displacement, etc. In which we understood that what is the difference between path length and displacement. We understood two names. One was your scalar quantity, another was a vector quantity. Okay. Please remember, I'm just trying to make you revise everything so that after this lecture is completed, you remember everything about rectilinear motion. Okay, so this is having a magnitude, and this is having both magnitude and direction. Okay, fine. So that is also been explained. So therefore, this path length was a scalar quantity, and this displacement was a vector quantity. Okay, what is rest all? So basically, path length can be path length is always greater than path length is always greater than your displacement value. Path length can be equal to displacement also, but displacement cannot be greater than path length. Okay. That being said, the next thing which we considered was average velocity and average speed, in which we understood what is average velocity basically. Average velocity is nothing but equal to x2 minus x1 upon t2 minus t1. Okay, so that is nothing but your displacement upon time. Similarly, what is average speed? Average speed is nothing but the total path length upon time. Fine, so that is how we conceptualized these two situations. One was average velocity and another was your average speed. Okay, so that was explained in first is done, second is done, third is done. Then next was your instantaneous velocity and speed. So in this we understood basically some sort of limiting calculus. So we understood that when we change this to limit delta t tending to 0 or delta x by delta t, so that is nothing but your instantaneous velocity. Okay, so that is basically instantaneous velocity, and this is also called as your dx by dt. That is differential coefficient of x with respect to t. Okay, please remember average velocity and average speed are same. Means not average velocity and average speed. Instantaneous speed is equal to the magnitude of average instantaneous velocity, and average speed is always greater than or equal to the magnitude of average velocity. Okay, why magnitude? Because speed is a scalar quantity and does not have any direction. Okay. Moving on, so in the fifth, we understood acceleration, in which we understood what is basically acceleration. It is nothing but v2 minus v1, average acceleration. I'm just telling you. So this is a bar upon t2 minus t. Okay. Understanding the similar concept regarding this, we understood that there is a concept for which is called as your instantaneous acceleration, which can be said as limit again delta t tending to 0 delta v by delta. It can be said as dv by dt. Okay, so that is how we understood acceleration also. Moving on to the final part, that is your kinematic equation for uniformly accelerated motion. In this, we understood three different equations. The first equation was x is equal to x naught plus at. Sorry, not really sorry, not for this. That is one of the cases. Let's not go into cases. We'll do it generalize. So first is v is equal to v naught plus at. Then x is equal to x naught plus v naught t plus half at square, and v square is equal to v naught square plus 2 into a into x minus x. So that is how we got these relations. First, we try to use a graphical method to find out this, and the next thing which we did was depending upon your using differential calculus. Okay, so that all the first we said, and we also understood free fall. We understood free fall concepts as in finding out what is basically free fall. That is only if the influence is due to gravity, and there is no any resistance force acting. Resistance force as in no air resistance etc. be acted upon, and what will be the resultant resultant acceleration? The acceleration will be constant only. What will be resultant? Let's say velocity, displacement, etc. And the time. Finally, after this, there was some example. Let's say about reaction time. Let's say about stopping at distance and Galileo's law of odd numbers, etc. And now we started in the last lecture regarding relative velocity. Okay, so now let us understand this relative velocity, and then let's move forward. Okay, so relative velocity. So in the previous discussion, I explained to you all these concepts which were written here. So just revising our last concept. So finally, what we got is that XBA. What is XBA basically? XBA is nothing but equal. XB of t is nothing but XB of t minus XA of t. Correct. So that being said, which is just putting these values here. So what is xb, that is equal to xb0 plus vbt plus vbt minus xa0 plus vat. Okay, this can be written as xb0 minus xa0 plus vb minus vat. Okay, if the displacements of the both objects initially are, let's say, 0, and what is the relative displacement happening? It is only depending on the relative velocity, which is vb minus va into t. Okay, so that equation is easily interpreted. It tells us, what does it tell? It basically tells us that as seen from object A. So as you know, please understand this. Okay, so now it's a complete game of using understanding the frame of reference concept. So let me try to devise this using a diagram here. Let us say this is your object B, okay, and let us say this is your object A. Okay, so it is as seen from object A. Okay, let us say this is moving at some velocity 20 meter per second. It is also moving with some velocity, let's say 30 meter per second. Okay. So now, as seen from object A, what does it mean? That we are attaching a frame of reference at this location here. So what does it mean? That this will have some standard coordinate axis, and a clock would be kept here. So that is mean that we are watching this is our frame of reference here, and we are watching the object B from this frame of reference. So that is how we use the frame of reference for our usages here. Okay. Okay, so let's start relative velocity concept now. So let us understand mathematically. Okay, let me complete this. So it tells us that as seen on object A, object B has a velocity VB minus VA because the displacement from A to B changes steadily by the amount VB minus VA in each unit of time. Okay, so as the time increases, this also increases. Okay. So we say that the velocity of object B relative to object A is VB minus VA, which is also written as, so now let us go to mathematical details now. So it is nothing but VBA. Please remember the first thing is written first, so it's VB minus VA. Okay. Similarly, the velocity of object A relative to object B is, so just reversing it, you will get VAB equal to VA minus VB. Okay. This shows that, what does it show? Simple. So it's just mathematical formulation now. So it's VBA is nothing but equal to minus VAB. Okay. So now let us consider some special cases. Okay. So let us take the first case. What is the first case here? We are taking the first case, that is VB is equal to VA. So what happens when VB is equal to VA? The first thing is also 0. The second thing is also 0. This is also 0. Okay. Then what happens? The xb of t at any time t, it is equal to the displacement is always same. As you can see, the displacement is always same. So let us say the first car was here at time t, the second car was here at some time t. Okay, so if it is always at time t and we are viewing it, it will always relatively, what you will see, that the displacement is always same one. That means where it was initial, we'll find it to be initial, looking as initial at some time t which is greater than your 0. Okay. So this thing is done. Okay. Therefore, two objects stay at a constant distance. Therefore, the two objects stay at a constant distance, which is equal to xb of 0 minus xa of 0, and their position time graphs are. So this is the position time graph. Are straight parallel lines parallel to each other as shown in the figure. So this is how a position time graph can be made for these two. Okay. So what can we infer from this? So that the value of xb at 0 location was this, and it at any time t it was same. Okay. So that is how we can infer this concept, that is, it is always same, so it won't meet at any time, right? So that is how we can understand this concept. So therefore the relative velocity VBA is, or therefore the relative velocity VAB or VBA is 0 in this case, which we just explained here also. Fine. Moving on to the next part, let us say now VA is greater than VB. So if VA is greater than VB, let us first understand. So first of all, let me write. So what is VBA? VBA is VB minus VA. What is VAB? VAB is VA minus VB. Okay, so as it is given that VA is greater than VB, so that means this thing is negative, this thing is positive. Right, let's move on. So one graph is steeper than the other and they meet at a common point. Quite evident. So this can be said as a slope, as we know that velocity are nothing but slopes of the position time graphs. So what we can say that VA is greater than VB, that means the slope of A, that means the slope of A would be greater than the slope of B. Okay, so this thing is also been explained. So quite evident, if they are having different slopes, that means there would be some point at which they will be intersecting each other. Okay, so one graph is steeper than the other and they meet a common point. For example, suppose VA is 20 meter per second and XA, that is at displacement at A, displacement of A at time t is 10. So this is given to you as 10. Okay, and VB is 10 meter per second, that means the slope is less, and XB of 0 is 40. Fine. So then the time at which they will meet is t is equal to 3 seconds. Okay, at this instant they are both at a position. What is the position? XA of t is equal to XB of t, which is equal to 70 meter per second. Okay, so just locate it like this and you will get the answer as equal to 70 meter per second. Okay, thus object A overtakes object B at this time. So first of all, object A was here, object B was here, and then object A overtook. Okay, object A was here, object B was here. Either the displacement was higher, but this was the point at which object A took apart and it went up. Fine. So in this case, what is VBA? So VBA can be calculated. How to calculate VBA? VBA is nothing but equal to VB minus VA, which is equal to what is the value of VB? VB is given as 10. What is the value of VA? VA is given as 20. Therefore, this will be 10 minus 20, which will give you equal to minus 10 meter per second. Okay. So in this case, this is given. So you got this answer. Moving on. Let's see. Now VA and VB are opposite signs. So that means one slope would be positive, one slope would be negative. Here also there will be intersection happening, but this intersection would be another than different than your B part. Okay. So for example, if in the above example, object A is moving with 20 meter per second. Let's say it's moving 20 meter per second, starting at 10. Okay. And object B is moving with minus 10 meter per second. So the minus means it is in negative direction like this. Okay. And initial was 30. Oh, just 1 minute. Sorry, initial was 40. This is your 40 value. This is your 40 value given. Okay. So the two objects meet at t is equal to 1 second. As you can see, this is the location at which they meet. Okay. The velocity of B related to A is what? So just simple. So don't be hesitant while calculating the relative velocity. Just use the simple formula and you are good to go. Okay. So what is VB? VB is given to you in the question as minus 10. So it's minus 10 minus what is the velocity A? That is plus 20. So it's this. So VBA is because basically minus 30 meters a second. That means if we are on the inside object A, then velocity of B looks like it is moving at a very higher pace, even higher than its original velocity. Okay, so that is how we can understand the situation. Okay, so in this case, the magnitude of VBA or VAB is 30 meter, which is 30 meter per second. VAB will be only negative of VBA. Is greater than the magnitude of velocity of A or that of B. Okay. If the objects under consideration are two trains, then for the person sitting on either of the two, the other train seems to go very fast. Okay, so you understood the relative velocity concept because the frame of reference is different as or in comparison to the ground. So therefore, because as you can see also 30, it is the value 30 is coming. So basically it is higher than both the velocities of both these things. Both these things as in the velocity at A and velocity at B. Okay. Note that above equation are valid even if VA and VB represent instantaneous velocities. Okay, so this thing is valid. So the relative velocity concept is also valid if we are considering instantaneous velocities also. So you can just keep this in mind. Okay. So two parallel rail tracks run north to south. Train A moves north with a speed of 54 km per hour and train B moves south with a speed of 90 km per hour. Okay, so let us try to write each and everything and we can go with each of these questions selected. Okay. The velocity A is nothing but equal to plus, if it's going north, it's plus 54 km per hour. Okay. Let us try to change it into meter per second. How to change it into meter per second? Just multiply it by 5 by 18 and you will get the answer as in what you can say meter per second. So it's 18 ones are, 18 threes are, which will give you 15 meter per second. Okay. Similarly, what is VB? VB will be nothing but equal to minus 90 km per hour. Why? Because it is going in south direction. Okay. So this is nothing but equal to minus 90 changing into meter per second, 5 by 18, 18 ones are, 18 fives are 90, which will give you minus 25 meter per second. Okay, so therefore BA is nothing but 15 and VB is nothing but equal to minus 20. So this thing we got till now. Let's understand the question. The first question asks is what is the velocity of B with respect to A? Very easy. So we just need to calculate the velocity of B with respect to A. That means which is equal to VB minus VA. What is VB value? VB is nothing but minus 25. What is VA value? Which is 50. Therefore, you got answer is equal to minus 40 meter per second. That's it. That is the first question, as you can see here also. So choose the positive direction of x-axis to be from south to north. Then VA is 15, VB is minus 25. So south to north as in south to north. That is positive direction. Okay. So relative velocity of B with respect to A is VB minus VA, which is equal to minus 40 meter per second. That is, the train B appears to A, train B appears to A as in with respect to A, appears to A to move with a speed of 40 meter per second from north to south. So this negative direction, what does it say? That it is moving north to south with a speed of minus 40 meter per second. Even though its original speed is 25 only, but when viewed from inside train, if you are inside train, then this would occur as in moving with 40 meter per second. Okay, let us move on the second question now. Second question says that velocity of ground with respect to B. Okay, just keep on writing. So velocity of ground with respect to B is nothing but equal to velocity of ground minus velocity of B. Okay, so what is velocity of ground? Velocity of ground is 0. What is velocity of B? Velocity of B is nothing but equal to minus 25. So this will be equal to plus 25 meter per second. Okay, so relative velocity of ground with respect to B is nothing but 0 minus 25, which is 25 meter per second. Okay, so this is the only consideration which you need to remember, that this velocity of ground can also be calculated like this. Okay, so you just need to put V3 which is equal to 0. Fine. Next question says that what is the velocity of a monkey running on the roof of the train A against its motion with a velocity of 18 kilometers per hour with respect to train A as observed by a man standing on the ground. Okay, so let us try to understand this question. So what they are trying to ask? They are trying to ask the velocity of monkey running on the roof of train A against its motion. So you just need to calculate the velocity of monkey. Okay, what is given in the question? It is given in the question that the velocity of monkey with respect to train A is given as 18 kilometer per hour. This is already given in the question. Okay, you can just convert this. Please remember here monkey is running against its motion. So if it is running against its motion, that means this velocity will be in negative direction. Fine. So because whenever even if you see from train A also, it will always go in the direction which is negative. Okay, so it can't go in the positive direction, right? Quite clear. Just try to assume this complete situation. Let's say you are traveling in a train right now. Let's close your eyes and try to observe the situation. You are traveling in a train and the top of the roof is transparent. Let us suppose if the monkey is running in the opposite direction of the train, let any be the velocity, it will always be in a negative direction to your movement, right? Let us say even if you are not even moving, the train is moving with the same velocity as you, so it will always go backward, right? So that means, what does it mean? It simply means that the velocity, this relative velocity will be negative 18 in this case. Okay, so just putting everything now, so everything is just from mathematical form only. So minus 18 will change into 5 by 18, which is giving minus 5 meter per second. So velocity Vma is nothing but equal to velocity of m minus velocity of a. This velocity of m is which is required here. This is equal to minus 5. So velocity of m is nothing but equal to velocity of a minus 5. Velocity of a is plus 15 minus 5, which is equal to 10 meter per second. So this is how you solve the questions regarding relative velocity. Okay, so only and only inaccuracy or error which you can do is that you can consider this to be plus 5. Okay, so please try to understand the situation, because it is written that the velocity of monkey running on the roof of the train against its motion. It is quite clear that the velocity to be understood here should be negative to the movement of A. Okay, if we are understanding it. So as the train was moving in the north direction, if you have understood that to be plus, then if it is moving backward, then the P and A should be equal to minus. Okay, so that was one consideration. Okay, so that is the end of this lecture. So now let us go to the summary and let us close this session. Fine, so that was a complete regarding all the concepts regarding relative velocity. So try to solve concepts regarding relative velocity at a much more clearer depth. So basic all concepts is just try to only places where you can do error in relative velocity is not understanding the VG part. Please remember always the velocity VG is equal to 0 only. Okay, and let's say if you need to calculate the value of VAG, that is nothing but equal to VA minus VG, which is equal to 0. So this is nothing but equal to this is equal to VA. Similarly, VBG, what is VBG? VBG is nothing but equal to VB minus VG, which is equal to VB. Okay, so that's how you solve questions regarding G. So G is basically ground, right? If let us suppose, I'm just trying to solve this question again. Let us suppose this was with the motion. Let's say that there was a train and the monkey was moving with the train only. Okay, so what would have occurred? Here VMA would have changed to plus 5. Okay, then it would have changed VM minus VA is equal to plus 5. VM is being asked, that is equal to VA plus 5. So it is nothing but 15 plus 5, which is 20 meters. So then the answer would have been 20 meters. Right? Okay. So that being said, let's move to the summary and then let's complete this session. Okay. So first of all, an object is said to be in motion if its position changes at time. The same definition which you have heard many times. So that is how we define motion. The position of the object can be specified with reference to a conveniently chosen origin. For motion in a straight line, position to the right of the origin is taken as positive and to the left as negative. Okay, so that is the basic sign convention which we take. So anything which we take, let us say this is the origin. Okay, so anything which we take to the right hand side direction, which is taken as positive, and anything which we take in the left hand side direction is taken as negative. Fine. So that was the first point. Second point is path length is defined as the total length of the path traversed by an object. Okay. The third point says that displacement is the change in position, that is delta x, which is equal to x2 minus x1. Okay, please remember. So this thing is very important as it is the starting. I will revise this again. Every time this Greek letter delta x, let us say if I take delta x into scenario, so this will be x final. Please remember it is always final first minus initial. Okay. Similarly, if I take for delta V, this will be V final first because people make mistake here also. Okay, sometimes they take initial value first. Okay, so please don't make that mistake. It is always final minus initial. Okay, rest all what can be said delta A here. So it is nothing but A final minus A initial. Okay, so this thing is also explained. So therefore, displacement is the change in position. The displacement is the change in position, that is delta x, which is equal to x2 minus x1, which is path length. That thing is done now. What is path length? The path length is greater or equal to the magnitude of displacement between the same points. Okay, so how can we explain this? Let us say we're at this location. Now, if we move to this location, then we went back, we went to this location, and then we went and we ended up at this location, right? What is the path length? This will be this plus this plus this. Correct, but what will be the displacement? This will be only this, right? So what we can say that the path length can be greater than or equal to. How can it be equal? Let's say we have moved from this location to this location, only we stop. The path length is also this only, and the displacement is also this length. Okay, displacement can also be 0, but the path length, if it is moved from its original position, it cannot be 0. Okay, fine. So that thing is also explained. Next thing is an object is said to be in uniform motion in a straight line if its displacement is equal in equal intervals of time. Okay, so let's an example. I also took the example when I tried to understand it. So let us take the example like this. Let us take that this is t, this is your x. So at some time t is 0, x was 0. At some time t it was 5. At some time 2 it was 10. At some time t it was 15, and so on. And that means that this is under uniform motion. Okay, so this is basically an example of uniform motion. Okay, so an object is said to be in uniform motion in a straight line is in a straight line if the displacement is equal in equal intervals of time. So as you can see, the displacement here is always same under equal intervals of time. So I took the intervals of time also as equal only. Okay. Otherwise, the motion is said to be non-uniform. Okay. So in our complete case scenario, we have generally took all the concepts as uniform motion only. Otherwise, constant acceleration questions were being dealt. Okay. Fine. So you know whenever you need to use uniform motion, whenever you don't need to use uniform motion. Okay. So that is how the definition of uniform motion takes into picture. Okay. The next thing is average velocity is the displacement divided by time interval in which the displacement occurs. So therefore, what is V bar? V bar is nothing but equal to delta x by delta t. Okay. So just arriving in this situation again. So this is how it can be defined. So it is nothing but x2 minus x1 upon t2 minus t1. Okay. Fine. Next thing is on an xt graph, the average velocity over a time interval is the slope of the line connecting the initial and the final position corresponding to their interval. Okay. So this is an example for this. So how it can be explained? Let's say this is t, this is x, and we drew some example like this. So if we need to calculate the value of slope from this to this, what we will do, we'll just join these two like this. Okay, if I need to find the value of slope at this location, what we will do, we'll just join this and we'll find the slope. Okay, that is how the slope will be calculated. Okay, so on an xt graph, the average velocity over a time interval, what is it? It is the slope of the line connecting the initial and the final positions corresponding to that interval. Right? Next thing is average speed. What is average speed? Average speed is nothing but the ratio of total path length traversed and the corresponding time interval. Average speed of an object is greater or equal to magnitude average velocity over a given time. Okay, so this is very important. I will just write it here so that revision is also taken place. First of all, you should remember that path length is greater than or equal to displacement. Okay, and next thing is because of this, average speed is greater than or equal to average velocity. Fine. So that being said, let's move on to the next thing, that is instantaneous velocity or simply velocity. Okay. So instantaneous velocity or simply velocity is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. So how to write this? We write this as in this form. That is v is nothing but equal to limit delta t tending to 0. Limit delta t tending to 0, a bar which is equal to v bar which is equal to limit delta t tending to 0 delta x upon delta t, and this differential can be written in calculus, which can be written as equal to dx by dt. Okay. The velocity at a particular instant is equal to the slope of the tangent drawn on position time graph at that instant. So similar to this position which we understood here about xt graph. So similarly we can understand this for your vt graph also. So what they're just saying that the velocity at a particular instant is equal to slope of tangent drawn on the position time at that instant. So basically, if you need to find the velocity here, what you will do, you will just draw a tangent here. Similarly, if you need to calculate the value of velocity here, you will just draw a tangent here, and that the slope of that tangent will be nothing but the velocity. Keeping in mind that this is the next graph. What is an xt graph? Xt graph is also known as your position time. Okay, fine. Next thing is average acceleration is the change in velocity divided by that time interval during which the change occurs. So what is basically a bar? A bar is nothing but equal to delta v by delta t. Okay, so that is being said. Next thing is instantaneous acceleration. So similar to this instantaneous velocity, what you will do now is this a is nothing but equal to limit a bar, which is delta t tending to 0. So just putting this, so in terms of a bar, what we will write this time, we'll write del v upon del t. Okay, so in differential form, this can also be written as dv by dt, which is being written. Okay, next thing is the acceleration of an object at a particular time is the slope of the velocity time graph at that instant of time. Okay, so what does this line say? I will try to explain again. So this line just says that let us say I make a velocity time graph Okay, so at a particular time, let's say this is the velocity time graph. So it is the same, and the acceleration is nothing but the slope of velocity time graph at an instant of time. So basically, if you draw a slope, or let's say these are two velocity at which you need to find out the average acceleration. You just join these two, and the slope of this will give you the average acceleration. Okay, and for instant area, it is the slope of the tangent on at any of these locations. Right. So that is the acceleration we done here. Okay, so the acceleration of an object at a particular time is the slope of the instant velocity time graph at that instant of time. For uniform motion, acceleration is zero. Please remember, for uniform motion, acceleration is zero. Why acceleration is zero? Because please remember, I will try to understand, make you understand this line also. So because for uniform acceleration, for uniform not uniform for uniform motion, not uniform acceleration. For uniform motion, delta x is always same for every delta t. What does it basically mean? That dx by dt is constant. Dx by dt is constant. Correct? So if dx by dt is constant, so on dx by dt is constant, which is equal to, let's say, k. If not k, it is equal to your v. Okay, so if it is equal to v, so we know what is acceleration. Acceleration is nothing but equal to dv by dt. So if it is equal to dv by dt and v is constant, we have understood from the concepts of differentiation that anything with a constant is nothing but equal to zero. So that is why it is written that for uniform motion, acceleration is zero. Okay, and the xt graph is a straight line inclined to the time axis. Okay, xt graph is a straight line inclined to time axis. That means this is how an xt graph is made. Okay, and the vt graph is a straight line parallel to the time axis, and a vt graph is a straight line parallel to the time axis. So that is how a vt graph is made. And how is an at graph? At graph is a again line which is zero. So this is how a vt graph is being made. An at graph is being made, and a let's say I draw with a blue line, and this is how an at graph is. Okay. Right, and the vt graph is a straight line parallel to the time axis. For motion with uniform acceleration, what happens in uniform acceleration? Xt graph is a parabola, while the vt graph is a straight line in the time axis. So what does it say? We'll try to explain this also. It basically says that for motion with uniform acceleration. So what happens in motion with uniform acceleration basically is that xt graph is a parabola. So this is x. This is how some sort of parabola is being made. This time, velocity time graph will be a straight line inclined to the time axis. Okay, so this time it will be inclined to a time, some sort of this. Okay, that is how what happens in uniform acceleration. So what happens in uniform acceleration? Then this time the acceleration time graph will be constant. Okay, so that is how these things have been explained. I try to explain each and every word which is written here. Okay, so for motion with uniform acceleration, xt graph is a parabola, while the vt graph is a straight line inclined to a time axis. Okay, fine. Moving on, final points. So the area under the velocity time curve between times t1 and t2 is equal to the displacement of the object during that interval of time. Okay, so for example, let us say I give you the situation and I asked you to calculate the value of displacement occurring in the time interval t1 to t2. Okay, so what you will write here, let's say we understand the situation in which t1 is 0. If t1 is 0, so what we can say, what is the complete this, let's say this is the velocity v, then the area value is nothing but capital V into t. Right? Similarly, let us say if this is the value of the velocity time graph, or area will be nothing but half, let's say this is capital V, so it's half capital V into t. Okay, similarly, let's say there would have been a parabola. right? So how would have calculated? We would have just found out the equation of this graph, and we would have integrated it. So it's nothing but integration v dt from 0 to t. We know the value of, we would have known the function of b as a function of t. We would have calculated that, and we would have got the answer of the area under the curve. Okay, so that is how the area under the velocity curve can be utilized and can be used for the calculation of your this velocities. Okay, fine. So that thing is all. Okay. Now next thing is that for objects in uniformly accelerated rectilinear motion, we understand each and every line here, every word here. So it's uniformly accelerated. What does it mean? Acceleration is constant. Okay. Rectilinear motion. What does it mean? It simply means that the motion is only in a straight line. So either it's moving forward or backward. Okay. The five quantities. What are the five quantities? These are displacement, time taken, initial velocity, and final velocity, and acceleration e. Okay, so these five quantities are being utilized here, which are related by a set of simple equations called the kinematic equations of motion. Okay, so these are the kinematic equations of motion. So in exams, this may be asked. You need to derive this as a graphical using method of calculus. Okay, so basically for method of calculus, we did an example also in which we understood these are concepts, and we also tried to find it using the graphical or the numerical form. Okay, so for this derivation, we simply use the area a bar calculation. For this derivation, we basically used how to the graphical form in which there was a triangle and the rectangle being made, and finally in this we use the average velocity concept, and the first equation was being used finally. So this was being utilized, and then finally we got this third result. Okay, for finding these all concepts using simple differentiation, so basically we can use like velocity is nothing but equal to dx by dt, and similarly we can also use a is nothing but equal to dv by dt and obtain all these results. Okay, I think we also used one more in which we used this a nothing but equal to dv by dt, which is nothing but equal to dv by dx into dx by dt, and then we converted dx by dt to v dv by dx, and then we just integrated this all, and then we got the third equation. Okay, so that is how you can do this by calculus also. You can do this by graphical plus numerical method also. So just try to practice this, just try to revise these all concepts, because these all things can come in the exams. Okay. So that being said, okay, so just and also remember these formulas. So these formulas are very important. So v is equal to v naught plus at, v is equal to v naught plus at, x is equal to v naught t plus half at square, and v square is nothing but equal to v naught square plus 2x. Okay, is the position of the object at time t is equal to 0. If the particle starts at x equal to 0, x in the above equation is replaced by x minus x naught. Okay, so this equation remains the same only. It is v is equal to v naught plus at. This is nothing but change to x is equal to x naught plus v naught t plus half at square. And this is changed to v square is equal to v naught square plus 2a into x minus x. Right? So that is the end. Just a few more examples, just consideration of revision part only. Okay, so let us say that if it is having on the free fall. So in free fall, what are the general considerations we use? First of all, everything is converted to y terms first of all. Then initial velocity of initial displacement y naught is taken as 0. We take it from that point of frame of reference, that is taken as origin basically, and acceleration is taken as minus g. If nothing is given, always take it as minus 9.8 or minus 9.81, or in some questions it is approximately as 10 meter per second. Fine. This is also explained. Fine. So that is the end, I guess. Okay. And final thing was relative velocity. So in relative velocity, what we understood, relative velocity is basically all the things which you need to remember. First thing which you need to remember is nothing but xb of t minus xa of t is nothing but equal to xb at 0 minus xa of 0 plus vb minus va of t. Okay, so therefore what we can write? We can write the velocity vba, that is velocity of p with respect to a, can be written as equal to vb minus va. Similarly, we can also write VAB is equal to VA minus VB. Right? So this thing can be written, this thing can be written. Also, we can say VBA is nothing but equal to minus VAB. Okay, that's all. So that was the complete chapter. We also understood some of the questions regarding means these were all different concepts only. So SSD was being understood. Then Galileo's odd number rule was being considered. Dual number in which the amount of displacement is happening is basically in the ratio of 1, 3, 5, 7, etc. Okay, so just try to solve different questions regarding this. And what else? Is anything remaining? Fine. So, okay, fine. So yes, so that is the end. So just final course progress for you. We started with the introduction part in which we understood the complete motion in a straight line. Then the next part concept we understood position, path length, and displacement. Difference between path length and displacement also. Then the third we understood average velocity and average speed, the difference between both of them. Okay. Then the next point we understood instantaneous velocity and speed and acceleration. And finally, in the fifth concept, we understood kinematic equations for uniformly accelerated motion. Please remember, it is for uniformly accelerated motion. So always acceleration is constant. Okay. And finally, we understood the concept of relative velocity. We had a question regarding this, and then we did the summary, and that was the end. That is the end of this chapter. So thank you for listening to me. We may meet in some other lecture. Okay. So thank you so much.